Hi everyone, I'm Yoonjoo from KAIST. Today I'm presenting our paper DAPIE, Interactive Step-by-Step Explanatory Dialogues to Answer Children's Why and How Questions. This work was done with Taesu, Sungdong, Yohan, and my advisor Juho. Asking why and how questions is an important theory-building mechanism for children, as answers to those questions can help the child gain an understanding of the world. As children can frequently perceive gaps in the knowledge, they require responders who can provide quality answers to their questions in time. Additionally, if they know that someone is available to respond and provide good answers to their questions, they can become encouraged to ask more questions, which leads to more learning. For these children, conversational agents like Alexa or Google Assistant could be valuable responders. Through CAs, children gain access to the huge amount of information available on the internet without being fluent in reading or writing. Moreover, CAs are always available to answer children's questions and are becoming increasingly common. However, most CAs are powered by computational pipelines that leverage data that was not composed with children in mind, and their answers are frequently inadequate for children. For example, when the child asks why do polar bears have white fur, ACA answers with lengthy reasoning like this. It is challenging for children to understand these answers because responses often require the child to interpret complex reasoning chains and to possess the prior knowledge needed. Furthermore, existing CAs provide long responses at once without interacting with the children, so they cannot identify what a child did not understand or cannot engage the child in the conversation. To answer children's why and how questions by leveraging the availability of CAs and their access to information on the web, we aim to transform existing long answers into interactive conversations that can enhance children's understanding and engagement. To understand what type of dialogues would be effective for children, we reviewed the rich body of work on child development, cognitive psychology, and education, and also consulted the experts in these domains. Based on this investigation, we constructed design guidelines for interactive dialogues for children. To help children understand complex concepts while avoiding significant cognitive load, we suggest that explainers construct chains of explanatory units. Specifically, explainers should decompose the explanation into subunits, identify relevant subunits and their relationships, and present their units based on their identified relationships. Additionally, we recommend that explainers expand on these chains to carry out interactive dialogues that engage with the child and adapt explanations to the child's level of understanding. These expansions should be based on the key components of effective dialogues with children: feedback, explanation, and question. When a child cannot understand an explanation about how bees make honey, in the explainer's response, green is feedback, blue is explanation, and orange is the question. To help children understand new information and be able to get additional alternative explanations, we propose that explainers adjust their explanations at a local level, such as providing examples or analogies, and also at global level, such as simplifying all the explanations and explicitly mentioning the coherence between all turns in a dialogue. After providing information to a child, the explainer should ask questions to the child to invite them to participate and engage in the dialogue by answering the question. Our guidelines suggest 3 roles for questions: guiding the child to new information, diagnosing their understanding, and eliciting their prior knowledge. Based on our guidelines, we propose DAPIE, a novel system that automatically transforms existing long-form answers into interactive explanatory dialogues for children. Our pipeline follows the 2 main processes from our guidelines. First, constructing chains of explanatory units from the long-form answer, and second, designing an interactive and understandable dialogue by augmenting these chains. We compose the first process of the pipeline as our guideline recommends: decomposing, identifying relevant units and relations, connecting the units. First, we started from an existing long-form question-answer pair. Our pipeline splits a long-form answer into sentences and judges their relevance to a given question to identify what is important or auxiliary information with a T5-based discourse analyzer. Here, M means main unit, D means detailed unit. Then, the sentences are connected to each other according to their pairwise relevance score in order to form a tree dialogue structure. Relevance score is computed through next sentence prediction by BERT model. In the second phase, our pipeline augments the initial dialogue tree by incorporating feedback to children's utterances, questions to interact with the children, and adjusting the explanations to scaffold their understanding. We designed these augmentations based on our guidelines, using guiding, diagnosis, and prior knowledge questions, as well as simplification and example-based adjustments. Our pipeline uses an LLM, specifically GPT-3, to simulate dialogues where a CA interacts with a child to generate these different forms of augmentations. In the second process, the pipeline simplifies all the explanations in the initial dialogue tree, as our global strategy suggests. Then, the pipeline integrates guiding questions that can help children engage further with a topic by previewing information to come. To generate these questions, our pipeline uses the turn-in painting technique by constructing a template with two consecutive explanation turns, TN and TN+1, and asking the LLM to fill in the template. Using the same technique, coherency phrases are also added to bridge children's understanding across consecutive turns of the dialogue. To verify whether a child understood an explanation in turn or not, the pipeline generates diagnosis questions that asks the child a multiple-choice question about the explanation they just heard. Then, to help the child understand, the pipeline generates adjustment subturns that provide scaffolding. For example, in cases where the child gives the wrong answer and the explanation contained a difficult term, the pipeline generates a question to elicit child's prior knowledge, like, "Do you know what ancestor is?" Then, depending on the child's answer, the subtree provides different adjusted explanations to the child, like either defining the term if they don't know it, or giving an example if they do understand the term. After receiving the needed adjustments, the dialogue proceeds to the guiding question to the next explanation in the dialogue. This is how our system performed.
How did people make languages?
Once the child clicks on question "How did people make languages?", DAPIE starts providing a step-by-step explanation. For each turn, DAPIE's utterance is shown on the panel above and spoken through text-to-speech. In this dialogue, DAPIE starts by providing a sub-explanation.
The first languages were easy sounds made by our ancestors.
After the child clicks on an option, DAPIE says the next utterance.
Let me ask you a question. What were the first languages?
Easy sounds. Complicated sounds.
In this case, it provides diagnosis questions to check whether children understood the explanation or not. Again, once DAPIE stops speaking, it presents the child with options to respond with. If the child failed to listen to an option, they can click on it to listen to it again. To validate our pipeline, we conducted human evaluations of the 5 main submodules used to generate the dialogues: simplification, exemplification, guiding question, diagnosis question, and elicit question. We used 32 QA pairs in natural phenomena, biology, physics, and culture and social conventions domains. Based on evaluation questions for each submodule, we asked evaluators to compare QAs from our submodule against the corresponding baseline. As the results shown, outputs from our pipeline were assessed favorably compared to those from the baselines for all of the submodules. We also conducted a controlled user study to investigate whether interactive conversations from DAPIE can improve children's understanding of concepts and increase their engagement compared to a simpler CA that provides the same information sentence by sentence. First, we evaluated children's understanding through an assessment after the dialogues, and children's score when they used DAPIE significantly outperformed scores with the baseline. We observed that this greater understanding with DAPIE was due to how it provided adaptive explanations according to the children's challenges. By analyzing the participants' behaviors, we observed that DAPIE could promote engagement. Children's gaze distraction and the number of nonverbal comments made when using DAPIE were lower than when they used the baseline, and verbal comments made are higher than when they used the baseline. In terms of usability, overall, the children felt that the dialogues from DAPIE were more enjoyable and trustworthy than the baselines. In our study, children and parents alike were positive about DAPIE. The child also said that DAPIE was a good teacher as its explanations were easier and it helped the child understand new information. Some parents emphasized the benefits of the adaptive explanation provided by DAPIE. Parents also commented about how they liked DAPIE's more accessible explanations and its correction feedback and related this to their own challenges in delivering scientific information to their children. By transforming existing long-form answers into interactive and stepwise dialogues with DAPIE, children can get answers to their own why and how questions without their parents' help. Additionally, we envision how DAPIE can serve to create shared experiences between parents and children. Beyond children, we believe that our approach for transforming existing information into dialogues could be extended to support active reading for adults by creating document-based dialogues that guide readers to other relevant parts of the document and provide adaptive interventions. For more information about the guidelines, pipeline, and the implications of DAPIE, please check our paper. Thank you.